Let's look at the remainder theorem again. Now, remember, basically, what it says, if you have a polynomial f of x, right, and it's divided by x minus a, the remainder will be f of a. Alright? So if you put a, if you substitute a for x and work it out, what you get will be the remainder if you do the actual division. Now, suppose you have a polynomial. Let's say x minus 3 multiplied by x minus 4, a quadratic polynomial. Here, what it says, if you divide this by x minus 3, what will the remainder be? The remainder will be 0. Now, the remainder theorem says the remainder will be 0. That means x minus 3 will be a factor. Alright? Remember that what the factor theorem says is that if you divide this by x minus 3, and x minus 3 is a factor, right? Or if f of x, if f of 3 is 0, then x minus 3 is a factor. What the remainder theorem says is that the remainder, when divided by x minus 3, will be f of 3. And if you find it to be 0, the remainder to be 0, then it means f of minus 3 is a factor. But that's for the factor theorem. Let's go back to the remainder theorem, and so on. Now, if you divide by x minus 3, you get x minus 4. The remainder is 0, because it would be plus 0 over x minus 3, right? It's just like if you have 10 divided by 5, you get 2. Remainder 0, alright? It's same as saying 5 times 2 divided by 5. You get 2, remainder 0, which is 2 plus 0 over 5. Same principle applies. Now, let's look at this thing again. Here, we see that if you put in f of 3, what you would get is 3 minus 3 times x minus 4, right? Which is 0 times x minus 4. The answer is 0. So, if you find f of 3, if you divide by x minus 3, the remainder will be f of 3. F of 3 is 0. Alright, the remainder is 0, as you see here. You see that? Now, going to try a little thing. Suppose I do this now. I say plus 5. X minus 3 is divided by, x minus 3 by x minus 4 plus 5 is divided by x minus 3. What happens here is this. You'd have x minus 3 times x minus 4 plus 5. Each of them separately can be divided by x minus 3. See that? And this is equal to x minus 3 cancels x minus 3, right? So you have x minus 4, good, plus 5 divided by x minus 3. It's the same thing as if you say, what is 5? What is let me see now, 27 divided by 9. You get 3, remainder 0. But if I add 5 to 27 and say 27 plus 5, all divided by 9, it will be the same as 27 over 9 plus 5 over 9, which is 3 plus 5 ninths. So the remainder is 5. Don't believe me? Let's do something here. 27 plus 5 is what? 27 plus 5 is 32. 32 divided by 9 is what? 9 into 32 goes 3 times. It's 27. Remainder 27. 28, 29, 31, 32. Remainder 5. Right? So here we have a remainder of 5. So this now, this is the remainder, just like how this is the remainder. So if you add 5 to this, you get 5 as the remainder. Now let's look back at what's happening here. Up here. What we have here is x minus 3 times x minus 4 plus 5, all divided by x minus 3. Now, remember what the remainder theorem says. If all of this is divided by x minus 3, then the remainder is equal to f of 3. Let's substitute 3 for x and see what happens here. Alright? Now, f of x is equal to x minus 3 times x minus 4 plus 5. Therefore, f of 3 is equal to 3 minus 3 times 3 minus 4 plus 5. 3 minus 3 by 3, 3 minus 3 is 0, 0 times 3 minus 4 plus 5 is equal to 0 times 3 minus 4 is 0. 0 plus 5 is 5. So the remainder is indeed 5. So you see that? So the remainder here is 5. Now, it shows evidence that the remainder theorem is not lying. It is true. Alright? Now, we did this division and we got 5. F of 3 is equal to 5. Remember, before we added the 5 to it, we got remainder 0. When we add 5 to it, we got remainder 5. Alright? So that's what happened here. Now, let us multiply out the x minus 3, x minus 4, and divide by x minus 3 and see what happens. X minus 3 times x minus 4 is what? This is x squared minus 4x minus 3x plus 3 fourths 12. So we have x minus 3 being divided into x squared minus, this would be 7x plus 12. Let's use long division and see what happens here. Now, we expect to get a remainder of 0. So let's see. X into x squared goes x times. X times x is x squared. X times negative 3 is minus 3x. We subtract. Negative 7 minus negative 3 is the same as negative 7 plus 3, which is negative 4x. 12 minus 0 is 12. X into negative 4x goes negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. All of this minus itself gives you 0. So you see that? remainder 0. Now, we added 5 to it up here. If we multiply out x minus 3 times x minus 4 and then add 5 to it, let's see what we would get. Let's erase the working before, because we're going to do a division again. 12 plus 5 is what? It's 17. Let's go. X into x squared is x times x is x squared minus x3 is 3x. Subtract. Negative 7 minus negative 3 is negative 7 plus 3, which is negative 4x. Then 17 plus 0 is 17. We bring the 17 down. X into negative 4, x goes negative 4 times negative 4 times x is negative 4x. Negative 4 times 3. Then negative 3 is a positive 12. 17 minus 12 is 5. So you see there we have the 5 as the remainder. Alright? So that's the remainder theorem. If you have a function divided by x minus a, the remainder is f of a. Alright? That is the remainder theorem. I'll see you in the next video.